Okay, good afternoon, everybody. Very welcome to our webinar today. Thank you for taking the time to attend. The title of this webinar today is the impact of climate change on offshore wind energy. This session will explore how climate change is reshaping offshore wind energy. We'll examine the environmental impacts such as rising sea levels, shifting wind patterns, and extreme weather, and their implications for the design, construction, and operations of the offshore wind farms. The discussion today will cover global risks, renewable energy targets, engineering challenges, and future risk trends, offering practical insights to adapt strategies and ensure resilience in a rapidly changing climate. So we're very happy today to be joined by John Colquhoun, Director of Forensic and Accident Investigations at Rimkus. John is a chartered engineer and a leading expert in forensic and accident investigations across the global telecommunications, power and energy sectors, including generation, storage and distribution. He's an expert in fire investigations, engineering failures and personal injury analysis. He's also an expert in wind, hydro, solar, battery storage and nuclear power generation incidents, providing comprehensive assessments of complex engineering challenges. So today's webinar is part of our series being delivered by Rimkus. Rimkus is a worldwide provider of engineering, technical and construction consulting to corporations, insurance companies, law firms and government agencies. So we're very grateful to them for giving of their time and expertise today. I'll hand over to John now, and we can pop your questions in the chat function at the bottom, in the question function, and we can pick them up at the end. So over to you, John.
Yeah, good afternoon, everyone. Welcome to attend. I'm just going to sit myself in my seat now. Yeah, really just this one is a presentation on the impact of climate change, obviously in the onshore wind energy, which is really sort of key to looking forward to where we're actually going to be going. And the next slide, you'll be glad to know, is the only thing that's going to talk about Rimkus. And since we've had such a great introduction, this will be part of the deck slide, so I'm not going to talk about this. If you've Googled who I am and where we're at with Rimkus, then you'll obviously see the services and provide that we can provide. So why you've turned up today. We're actually going to look at climate change, global risks. Then we're going to look at renewable energy strategy, offshore wind energy, risks and claims, and then obviously I'm going to wrap that up at the end. So climate change and the global risks, really why we're here. This is what we're looking at is a global temperature rise below 1.5. Now, that 1.5 that we're trying to adhere to means that we will still have heat waves, we will still have droughts and floods, there will still be rising seas. Ocean changes, Arctic ice thaw, species loss, you name it, that's what you're talking about there at 1.5 degrees. It's not a 1.5 degrees to stay where we're at the moment. 1.5 is where the science says that we're actually going to hit that tipping point into major events that will affect human life on the Earth. So obviously, one of those main drivers for that to stop that climate change or slow that climate change down is that fossil fuels are to be eradicated from our supply chain. And that's in domestic heating, industrial heating, the transportation and all the rest of it. So we're moving away from that. We've all had the initiatives to go to electric vehicles. We're all looking at things like biomass plants as that, the sort of stuff that we can do as consumers. So to enable that transition, we're looking at more offshore and onshore wind, tidal and wave, biofuels, solar and PV, hydroelectric and nuclear as well. Obviously, the UK announcing its small nuclear reactors last year. Now, what actually is climate change? You're talking heat waves, you're talking expansion in power demand. And that is both on the heat wave and obviously in the change, the flip to that one. I don't know if any of you know that with the climate change models, certainly for me in Scotland, climate change models say that Scotland is going to get colder and damper, if that's possible. So really, it's not just a case of looking at heat wave, it's looking at a case of actually how that's going to impact the environment that we live in. Obviously, there's going to be ocean changes, so higher sea levels. So then you're looking at offshore wind turbine foundations. Do they need to cope with the greater water depths? Do they need to cope with higher winds, which then leads to higher wave conditions as well? And obviously, what do we do with those existing foundations as well? Do they need to be modified to obviously future-proof those turbines across their 25, 30-year life? And if they get regenerated, then do we still have to, or can we still use those routes as well going forward? Obviously, the blades and the mass as well. Again, reassessment on your wind speeds. Some of the cyclone damage that we've seen in certain regions in Asia and things like that as well. Those turbines have been basically destroyed because we're having much more extreme events as well, much higher wind conditions that we're looking at. The problem being is that that's not helping with energy generation. It just means that we have these one-off events that can come in and do catastrophic damage, and then the next month after that, you have a doldrum of wind conditions. Sorry to go back to our lives a couple of years ago, but really that brought a lot of focus into pandemics and how we operate pandemics and what happens with pandemics as well. And again, with climate change, the possibility for these global pandemics increases as well, as along with global travel, global economy, and global commerce. And I suppose this is one where it's again the pandemic explosions on access, on generation. These have all been refocused on, given what happened during COVID. But again, it's just a reiteration that pandemics happen all the time. It's through human history. You get the Black Death. You then get the Spanish flu, like, for example, in the early 20th century. You've then got COVID in the 21st century. Ebola's another, these sort of things. Something else will come along in the future that will cause us to have a look back at what these global risks actually are. And that falls back into global warming again. Russia's invasion of Ukraine, and we have other aspects as well to do with the Iran situation. Venezuela is another. Certain regions where we probably the South China Sea as well, where there's real focus on natural resources and what that's producing, where even things like the global supply chain, where they're affected. If there's something coming from China, if it can't use the Red Sea, if it can't use the Suez Canal, the Panama Canal is closed, then you're talking about going back to the old days when we have to go down the Cape of Good Hope, past Africa, past the South America. That extends all these supply chains. And obviously then we're looking there as well as the hydrocarbon generation. Where does that come from? Where is the next phase coming from? Where are the next tensions? And how is that going to manage that? And that all drives us to what needs to be done. And obviously, global temperatures are still rising, and there are commitments globally. Certain countries are obviously less hot on this, if you like to call it that, than others. But there is definitely future growth in renewable energy, and we're basically driving that way to try and decarbonize our existence. Now, are the renewable energy targets realistic? I'm going to focus, obviously, most of the people here are in Ireland. I'm going to focus on what Scotland has been able to do within the framework of the UK. And for example, in 2017, the UK was 7th out of 114 countries, but a major part of that is actually what Scotland's generated. And of that, it's increased its renewable energy production by 26% from 2016. England increased its with 14%, Wales 34%, Northern Ireland by 40%. They're coming obviously from quite low bases. In Scotland, we've probably increased much more than that because we actually had quite a large base as it was in 2017. Now, bearing in mind the Scottish population is a tenth of that of England, we are very, very lucky in the grounds that we've got a third of the landmass of Britain, which then allows us to obviously have a lot of empty spaces. Let's leave it at that. What does mean that we predominantly on on wind generation, that be offshore or onshore. Solar isn't as much in Scotland, and it usually gets a bit of a laugh on this one, but actually there's terawatts worth of energy that's not being produced in Scotland because there's a natural presumption against solar and PV generation in Scotland, given our climate. But you have to remember that some of the sunniest places in the whole of the UK, probably the British Isles and in Ireland, are in Scotland, and yet there's a presumption of it against solar and PV installation. So that's got a lot of catching up to do within Scotland. I certainly see that sort of same sort of kind of reticence in Ireland as well when you probably talk about solar and PV. We also have the luxury in Scotland of having quite a few hydro schemes as well. For example, at Crowchan is one of those, and probably class hydro along with wave generation and tidal generation as well, which is really sort of three legs of the same aspect. And this is what we've actually got the capacity at the end of 2024. Again, if you're looking at Scotland, vast majority of that's wind onshore, whereas in England that's wind offshore, mainly the solar farm, the wind farms in the North Sea. But then they've obviously got a large proportion of theirs actually is installed capacity on solar PV as well. And that's where I think the likes of Northern Ireland, Scotland, Wales, and probably Ireland could really make a march on their generation using PV and solar. Again, really just hammering home what the generation is and how it actually splits out between the years and where we've actually grown in the past and where we started and where we're going to. So really just a split, and probably don't see much difference here between Ireland and the British Isles. Probably the one would be nuclear, which we've obviously that's a multi-generational investment for the UK with the likes of Hinkley Point and some of the other generation that we're actually doing. Those decisions should have been taken about 20 years ago, and they've really kind of lost the march on on nuclear. But luckily enough, they've got a lot of wind and solar, and really sort of taken up that bedrock where we've actually decarbonised on no more coal, and the gas has been reduced slightly, but obviously that gas product has to be reduced much further if we want to try and decarbonise our energy production. So, give you an idea, 2000, Scotland produced 1.4 gigawatt of electricity capacity. By 2012, it was 12.3, so a tenfold increase in the amount of energy production. What we're looking at there then in 2021, we're talking 27 terawatt hours of renewable energy produced. The vast bulk of that's obviously onshore wind, but catching it up very, very quickly is offshore wind as well. It doesn't look as much there at the moment, but we're certainly the plans in place for some of the wind farms in Scotland. Although most of those wind farms are in the North Sea, given the depth of the sea in the Atlantic, so that will probably tail off with more onshore wind in Scotland, given our demographic population density and where we're actually able to produce that the energy from. It makes sense to have onshore wind. Again, probably Ireland's very much the same. We're the bulwark for all the wind coming off the Atlantic Ocean. So I would say that probably onshore wind is going to be the major growth area within Ireland, given the next 5 or 10 years. Definitely, it has to be that. So where that equates to is basically there's enough energy to power Scottish homes for 3 years. We overproduce our renewable energy and export that. Now, it was about 16 terawatt hours, slightly down from 2020, but again, looking back to global warming, you're looking at doldrums and some recorded low wind speeds as well. So where you have, again, we're looking at these storms that keep on coming in, they look great for generation. Sometimes or most of the time the winds are too high, the turbines shut down, so you're not actually generating any electricity through these high storm events. Then you go back into a period of doldrum after that. So again, the modelers are actually having to look back at what they're actually doing. But considering that, there's about 3 gigawatt under construction. We've got another 7.3 gigawatts awaiting construction and another 5 gigawatts in planning. And that's just basically a mix of onshore, offshore, biomass, photovoltaic, So there's a big push as well on biomass plants and the waste to power, that sort of stuff as well. And then obviously we've got the luxury of having some hydro plants in Scotland, which were either increasing their capacity or what they're actually doing as well is dusting off the old plans from the 1960s and basically looking at those again and reevaluating some of those plans to then look at building brand new hydro. You can see there where the climate change emissions, we've actually got the climate change emissions target 2019. And they're basically looking that in 2020, our gross consumption was about 98% of renewables. And we look basically 2030, we're looking to generate 50% of overall energy consumption from renewable resources. And then obviously by 2050, hopefully to decarbonize the energy system. Now, I've put in hydrogen in here because it's a big silver bullet everybody keeps on talking about. I think there's lots of facilities that are out there. There's lots of companies that have started up that are going at this, but there are also in hydrogen, there are an awful lot of companies folding because they can't make the price work for them at the moment. And I think that's one of the areas where certainly it keeps on popping up as a potential energy source because you can produce green hydrogen from the wind turbines or the renewable energy and store that as an energy medium and then use it back into electricity when you need it. A bit like an alternative to a BESS system, a battery energy storage system. But again, the price point for the hydrogen just isn't quite there yet for it. So there's a lot of companies that come in, promise the earth for it, and then fold because essentially the economics isn't quite there. So are they realistic? Well, yes, but they need the political and social will. A lot of pushback on things like wind turbines. If the community isn't taken along with that, again, social and political gives you the funding and it gives you the behaviour. So that's the behaviour on how you interact with the community. That they basically have these wind turbines in their foresight of their foremind that they can see them, but they might not necessarily get the benefit from it. Also means materials and labour. And again, we're all in a war for talent. And obviously, we can see day in, day out the cost of things going up, supply chains being stretched. That's where you have the problems. Wind turbines, if you're ordering a transformer just now, you might wait 30, 60, 48 months for that transformer to be actually delivered on site. So you're looking at those elongated supply chains. And then obviously I've said about hydrogen, it's a bit of a phoenix. It kind of comes up and down, depending on whether we can do it or not. I love the one I've seen has been solar glass, which has been developed, which essentially replace the windows in your house or the windows in buildings, and it's actually still a PV panel or a solar panel essentially in your property. But again, it doesn't have that visual impact of a big panel on your roof. District heating systems are coming in. There's quite a few, especially in flats as well, where we're district heating systems, which are meant to be more efficient. But I would say there's no one size fits all. It's really down to a geographic location, really doing what suits you, what fits what the people want, and obviously how you're actually going to deliver that as well. But there's obviously one that I haven't talked about or alluded to a wee bit earlier on. Is nuclear classed as a renewable energy? And I've seen this, people trying to argue this one, and I've seen people being cute now. They're calling it a low carbon energy. So they're classing everything now as low carbon rather than renewable because nuclear materials is a finite resource. We've got about 100 years left of identified uranium deposits that we know of and we can harvest. So again, nuclear power isn't a renewable energy, but it kind of gets lumped into a low carbon. And then the holy grail, which is nuclear fission or fusion. Fusion, 40 years ago, was saying it's 40 years away. It's now about 20 years away, but they keep on going. The only thing with fusion at the moment is they can do it. It just takes more energy than it gets out. So once they crack that, that is basically the holy grail because it's infinite energy. So how does that affect offshore wind energy? So wrapping all this global energy, wrapping all this supply chain, wrapping all the effects and potential going forward of what we're looking at here. First one is obviously design practices, I would say, need to change. We've got recognised standard bodies and organisations that produce codes, but I think they really have to now start looking back and checking out, is the 300-year storm actually a 300-year storm? Or is it now a 100-year storm? And is your 100-year storm a 10-year storm? And so there's that constant evaluation of what you actually have to look at, what wind speeds, what wave heights we're looking at, and any of the other aspects that we've got there. I think it really have to be reevaluated again. You know, layouts. Do we lay out the wind farm, the turbines, so that we can withstand the windstorm? You're talking here, we're looking at 25, 30 years. Beyond that, even beyond if we repower them, you know, is the site location and the best location for that if we're looking over that length of period? Are we looking at turbines? We're now going to 15 megawatt turbines. They are huge. You might need less turbines, but every time one turbine goes down, it's a much bigger hit on your generation and your power that you actually produce. So you're really putting more eggs into the same basket. Is that the best idea, or is it better having smaller turbines but more of them? Again, it's going back to that, what suits your environment, what suits what you're actually wanting to do. No size fits all. And then you're looking at, how do you build them? You know, what's the power? What's the thrust from it? What's the rating? What do you do to control it? How do you shut it down? Do you get the most out of it? Can you operate these wind turbines at higher wind speeds? Do they actually operate at lower wind speeds as well? So you need, so those times, those doldrums that occur, are the fact that those are actually, we're getting better at actually capturing all that wind, all that energy at the same time. Now, you're then looking at the content of materials. I've seen some ideas of the materials for the blades of the turbines changing back to wood. They used to be made out of balsa. Going back to older materials to see whether or not we can have a look at those, because it might not necessarily be the best for the environment using GRP. But then somebody comes along and actually fixes that and says, actually, we've got a product here that they can make that GRP, we can repurpose it and reuse it. You know, do you have the blades leading the nacelle or behind the nacelle when it comes to which way it turns into the wind conditions? All these sort of things that are actually just driving the design and driving those sort of innovations that we really need to be looking at now for that 20 to 30 year sort of resilience. Some of the big the stands that we've seen here, and probably can be some of the most costly failures, are damage to undersea cables. So again, you're looking at the, you know, for scour protection, you're looking at the concept and the materials you're using. You're using at the shapes and size of what you're actually doing. You know, the structures, the met masts, all these sort of things that you're actually looking to do they affect other aspects of your wind farm? You know, they'll say here the undersea cables, you know, what routes might have made sense 5 years ago? Do we have to reassess those on shifting sands and the seabed? Are we looking at AC or DC generation for depending on which type of wind turbine and how far it is? You know, the cable protection, the how you weigh them down. Do you have to worry about terrorism? Do you have to worry about state-sponsored terrorism? Or is it just a case of, do you have to worry about cable dragging for vessels, for normal vessels, or for fishing vessels, things like that as well that could potentially damage cables? How do we look at those and how do we minimize those? Structural design. So the global warming is expected to change the wind wave patterns going back. So there might be things here that maybe not been considered before, or maybe not had to be considered before, such as like fatigue, that constant vibration through the tower. That then potentially could cause problems during critical loads, or also even as simple as having to tie wrap some of your electrical equipment inside in the cell, having to make sure that that's secure and it doesn't actually loosen itself off during the normal vibration that wind turbine exhibits. Again, reevaluating and reassessing your soils and geology, has that shifted through the time? And obviously there's ongoing studies that indicate that fatigue life decreases due to the effects of climate change. I mean, that's basically a no-brainer. You're putting more pressure on the wind turbine, more pressure on those nuts, bolts, and weld features. Again, do you need to actually increase your ppm, your visits to site, your assessments? When you're ultrasounding things as well, making sure that the erosion or corrosion that you've actually got is in line with what you expect. But what we find, we're looking at it, and the models are suggesting that the wind speeds will decrease as a result of climate change. But the converse flip to that is it will increase extreme weather events. There's also going to be changes in wind patterns and tidal patterns, and then a rise in sea levels. One of the ones that I look at is the Labrador conveyor. If you dump a whole lot of fresh water into the top of the Labrador conveyor, it essentially switches that off. That then potentially affects the Gulf Stream, which warms up Ireland and Scotland primarily in the colder weather. So is that going to then affect and increase our conditions that we get colder, we get wetter, we get snowier conditions? Do they have to be accounted for in the potential case that that happens, which, believe it or not, has happened in the past? And that's why we think Charles Dickens and White Christmas, basically Christmas Carol, that was at a time at which they think there was a slight hiccup in one of the either the Gulf Stream or the Labrador, which resulted in a mini kind of ice age, if you want to call it that, in the UK. That's how we get all these preconceptions, but it has happened in the past. Some of the things we're looking at, deep water floating structures, again, looking at the more harsh environments. These have all been lessons that have been kind of learned in oil and gas industry, and we're having to try and relearn them again for renewable energy and wind turbines. Obviously, you're talking about increased size of and the weight of the turbines. You've got then obviously the structural design considerations. You've got larger turbines, again, specialist vessels. You might find that if you have a wind turbine that goes on fire or fails, you might wait weeks, months, or even years before that specialist vessel is free for you to hire to come and work on that wind turbine. And if you've got a 15 megawatt wind turbine, that's a lot of money that's basically being lost out of generation. That has massive considerations for the financial repercussions on that wind farm. Excuse me. And obviously, the owner's sort of kind of financial modelling that they've done on the payback period. Insufficient skilled labour, that one as well, basically is, again, going back to the war on labour, on skills. Are people shifting from oil and gas into renewables? Are you looking at generational changes between what you have to what you need and where you need that? Or is it a case as well of actually working through, okay, what can be done remotely? What can be done with drones? What can be done with specialist sensors and monitors to actually reduce the labour requirements and allow you to use what we do have much more efficiently? We also have quite a lot of wind turbines that are reaching the end of their 20-year, 30-year lifespan. We've extended some as well. We've rebladed them. We're still going through that process. And in fact, there's a wind farm that's a couple of years ago, but it was regeneration in Scotland. It was an onshore wind farm. Essentially, we're able to do much more generation through less turbines now. These are sort of considerations that are out there as well. The other one I would say was, if you have a wind turbine that fails and has to be replaced, getting a direct replacement for that wind turbine can be near on impossible, because what used to be standard a 5 megawatt turbine now, you can't get a 5 megawatt turbine for love nor money. Therefore, maybe the smallest you might be able to get is an 8. The problem being is that for planning purposes is a material change to the size of that turbine. Therefore, you might have to go back through all your planning consent and with communities, etc. So that's a major consideration about whether or not you can actually renew that, replace that turbine, or what can be done with it. Do you have to actually write off the financial input that that turbine would have on the wind farm, because that's less expensive than trying to work out how to replace it. What we're doing about risks and claims, constructional risk claims look like in the future. Obviously, we think there's going to be more defect in design claims. I think they're currently design practices out of date. What we're looking at, where we're looking at it, and how those actual risks and claims arise. Whether someone has picked up the correct standard, whether they're building it to the correct standard, has it been updated and reviewed? We're also probably looking at more defective manufacture claims as well. Again, a lot of these wind turbines are pushing the boundaries. For one I heard was that when you bring a new wind turbine blade into manufacture, there will be probably maybe 5 prototype blades. And of that, possibly only one of them has gone through full failure analysis. And so therefore, you're building a fleet of wind turbines with blades on the grounds that you've tested one blade. So that's where you're actually going. And it works in the past. Saying it might not, not saying it won't work in the future. I'm just saying that sometimes these things, there's design in there that actually might find that requires complete design changes, and we're only really finding them at that point in time in which they actually fail in the field. And a lot of insurers are looking very closely at this one as well, because a lot of claims that we're seeing do feel like it's research and design by insurance. And so the companies are putting out the fleet because they're pressured to put out more fleet quicker. And sometimes the testing that's maybe being taken on that fleet isn't quite as good as what you think it would be. We're also looking at things like obviously the weather costs. Again, go back to climate change. You might get your vessel out there, you hire it for that week, you find it actually can't move out of port for that week. You're still paying the costs for that vessel. You've hired it for the week, it's up to you to use it. It's not their fault for a weather condition or weather off. And then what happens is, don't use them for that week, then you then lose that vessel for the next 6 months again, because someone else has paid for the following week. And probably the increased workmanship again, going back to redo PPM work or any other maintenance or refurbishment works. Are we losing that skill set? Are we making sure that the skill set is there? Is the training in place for that labour to actually do the work properly? Because it's a very expensive failure. Going back to it, especially if you're talking again, going back to specialist vessels as well, to actually minimise those losses. So get it right, get it right first time. So what we're looking at in the future, I think we're probably going to be looking at the failure cable protection systems. Again, with seabed movements, higher vessel turnaround, other factors, things like sabotage is another one. Obviously, there's a whole thing to do with certain fleets, certain vessels operating in international waters, where there's a potential or very high confidence rate that those vessels are bad actors. Some of the ones you've seen as well is with the higher tidal movements, higher sea levels. We've got unburial of sea cables. Again, excessive movement and damage. Vessel impact. There's obviously the ones where you've got vessels. If you've got vessel to turbine transfers, there's always the possibility a vessel can strike a wind turbine. I heard of one where there was a vessel that went on autopilot. Nobody was in the bridge, and essentially almost sailed right through a wind farm. It only really struck the wind turbine that was in the far end of the wind farm just through sheer luck. That's the sort of things that could potentially happen. Obviously, we're seeing maybe a bit more of an uptick in your manufacturing claims and design defects as well. Again, I think really from that is that rush to get the product out. certain companies racing with each other to get the biggest and best turbine out. Probably a check and balance on that one is making sure that as the testing being done, are we happy with it? And make sure that actually the materials that they're using are actually up to spec. And obviously then again, supply chain problems as well. We've seen an increase in the supply chain network. Are people buying and getting substandard materials to try and fill that gap? Just a quick summary. Really, it's climate change challenges. It's whilst it's a driver for us to have wind turbines out there, I think there's a lot more challenges coming down the road at the quality and where we're at with the wind turbines, what they're actually going to be sustaining, whether the longevity of it as well. Make sure that actually those wind turbines are actually there to produce the energy that we need. Because once we sort of kind of decarbonize our network, it's very difficult to go back or certainly have that redundancy in the network. That should wind turbines start to fail or be problems with a wind farm, how do you actually recover from that as a region, as a country, as a continent, on having mass outages? And we're lucky in some respects that there is that interconnectability, that we can actually move energy around Europe to try and stop those blackouts. But as we saw in the Iberian Peninsula, sometimes these blackouts can occur and they can contaminate across the kind of grid network that we have in Europe. So how do we manage that? How do we work with that as well? But obviously to do that, I think there's going to be an increased focus on the design, the installation, and really, to be honest, the maintenance of the wind turbines, because that's going to be key to making sure that these turbines, especially offshore, and if we go for wave and tidal power as well, the maintenance regime on these ones is going to be absolutely critical given what we're actually asking them to do. And I think that sometimes, in my experience, sometimes those operation and maintenance programs are the first things to be shaved, pared back, elongated, just because it's an easy hit for companies that are looking to save money. But that's really a short-term win. It's going to be a long-term failure. And this is obviously for me in an insurance sector, is going to see that that's where insurance companies start to ask really interesting questions about the reasons why your PPM schedule was changed and was that as per the manufacturer's guidelines. And that can then potentially cause problems on whether or not policies engage or not. Obviously, increased costs, again, reevaluating your supply chain, reevaluating your business interruption, your loss of generation cover, because what used to be a generator, say for example, a generator or a gearbox failed, it was 6 months supply, 8 months supply, 12 months supply, and those were all within your cover. What we're signing now, if it's a transformer, that might be 48 months. Now, do you have your insurance cover out to 48 months? Have you paid for that premium? What is your contingency plan? Should something like a critical piece of equipment fail, then actually what it is they actually get back up and running? And are you actually insured for that loss of generation or increased operational costs because of that failure? Circle back onto your conditions on your insurance policy to see whether or not that's something that's in there and what those date lines actually are, because they can shift depending on your policy wording as well. And really, this isn't just confined to renewable energy. You see this in all the utilities, oil and gas. We're all facing the same challenges with labour, materials, supply chains, and increased effects of climate change.